Hello and thank you for joining me again. It's Bit Repairs. This is Wayne and you're joining me this evening. First time I've done an evening stream actually. This one is basically going to be fixing a few phones that have been sent in. They're all from one customer. I just thought I'd see if instead of doing a stream at 7 o'clock in the morning, we could get something in, some more viewers in kind of later on in the evening, see how things go. To be honest, I wasn't planning on doing a stream, but I thought since I'm going to be fixing some phones anyway, I might as well do it whilst everyone's, well, if anyone does want to watch, whilst anyone's watching. So kind of, I'll wait until it gets in a little bit and then we'll see if anyone joins on. But basically what we're going to be looking at is these are all sent in from one customer. So one of them is an iPhone 7 for audio. That's routine. I've shown you how to do that in last video. Another one was sent in. I don't want to show you the back of it because it's probably got customer details on it. So this one says not working, not battery or Tristar, dead, question mark, question mark. So that's an iPhone 7 32 gig in gold. That one says that it's not working. This one here, I've already looked at it, it's an iPhone 8. It says backlight connector. So I've had a look at the connector on here. Connector looks absolutely fine. Can't see any issues there with that. So not sure what that might be. It may just be a blown backlight. I'll disconnect the battery on that. In fact, before I do that, I might as well try and get a bit of charge into that first in case the battery's dead before I look at it. It's always handy to get a bit of charge into these things. Don't know who's just joined on, but welcome. We're just doing a few bits and bobs, things that need repairing from one customer. So we're just going to kind of work our way through them. This one says Tristar. So they have identified this as being Tristar. It's only an iPhone 6, so we'll go through the Tristar repair on an iPhone 6 again. And that's about it. If I've got some more time this evening, we'll have a little look at, I think I've got an iPhone XR with no power. I've got a tablet, an iPad. Oh, I've got all sorts here. There's just so many phones here to fix. I've got a whole bucket here full of repairs that came in that should have been fixed today that weren't. So if you've sent me a repair in that arrived today, I do apologise for that not going back out the same day, but I was a little bit behind today. So yeah, basically that is the scenario today. Let's work our way through them. First one, a bog standard iPhone 6, bit of an antique now this one. So what do we do first on the iPhone 6s? The first thing we do is we plug a cable into the bottom and let's see what the ammeter tells us. So the ammeter is telling us straight away it's pulling 0.006. I'll show you on the fun cam. I don't really know what to call it actually, but yeah, I'll show you that. It is, hold on a sec, move that one over to there. There we go. That's camera number 4, so you can see that one there. So we're pulling 0.006. That is standard for a phone that has Tristar problems. So to be fair, I think that's probably right. So let us unplug that one. That should be Tristar. But before we try that, obviously let's have a look at the battery first and see if it's got a short, because sometimes it can display that Tristar problem when it's got a short. This one, this iPhone 7. Again, this one says dead, not Tristar, but I'm not sure. I beg to differ on this one, because if we have a look at the motion cam again, we can see that that is pulling 0.006, which is usually a dead sign that it is Tristar that's faulty again. So we may have two phones that have got Tristar faults here, which I wasn't exactly intending on that, but so it looks like so far we've got two Tristar failures. Let's put them there. One of them potentially a backlight, so they're claiming that this one's backlight. We want to check that first and make sure it's not no image. There's a big difference between no image and no backlight, so we'll look in different places, you see. And this one is just standard audio, so we've tested it before. So you go into here, into voice memos, and the button just doesn't do anything. You can tap it as much as you want, it will not do a single thing. So that's definitely audio, that's a standard audio, that one. So yeah, let's switch that one off, the one with audio. We know that is definitely audio now. So it's down as audio on the ticket. So I'm just going to stick a sticker on it now and actually label it up as audio. I like to clearly label these things so I know exactly what they are. So yeah, basically, as soon as I've diagnosed it, I'll label it up. These are easy peel labels, these are, so they can be peeled back off again dead easily. Seriously recommend you get some of these for repairs. Welcome to people that are just joined now. So we're just going to have a look through all of these repairs, and then we're going to see if we can diagnose exactly what it is. So let's start with I'm going to have a look at this iPhone 7 because it intrigues me as the fact that someone said it's not Tristar. So let's just get the base screws out and let's have a little look inside. I've got until around about 10 o'clock for this stream, so you know, a couple of hours, should be interesting. I want to try and get some newer ones done as well, maybe. If we get bored of these, then I've got some, I have got an XR here with no power to diagnose. I don't know, I just don't like, I feel comfortable doing the kind of more routine repairs on stream, but doing ones that could potentially end up in a no fix, then, you know, they're not as common repairs. So if I see a repair that I'm pretty sure I can fix, then yeah, I suppose I'll do a stream. Bit of a cop out, but I don't know. You know, it's up to you people. If you tell me I should try and do something, and you know, at least then we can try and help each other, give some pointers and that. So here I'm just going to pull these screws out for these shields here. And there we go, coming out. Absolutely love these screwdrivers as well. Don't know what screwdrivers you're using, but feel free to comment. These are the Kian Lee ones, Tool Plus. Absolutely amazing drivers. They've got a weird head on them. They've got like a flat head at the top. I should show you under the microscope. And then the actual screwdriver bit is absolutely tiny. It's just a tiny little tip at the top. So you have to have them dead straight on the screw for it to work. But it's good because you've got not a great deal of chance of rounding off the head. I kind of do this as a standard par. I'll always take this one off, which is the tri-wing one, because it's just easy to take off now while I'm still holding onto this screwdriver. So there we go, that's the screen off. Now let's have a little look and let's see with our multimeter. Let's get this back into continuity mode. I'm going to stick one probe on ground, the other one on the battery. So that's obviously the ground again on the battery, dead short. And the next one, interesting. So this one does look to me like it's a dead short somewhere on the board and not Tristar. So I'll show you that there. I'll just go onto the little handy cam. And then hopefully you will be able to see what I was looking at without this whole thing falling all over the show. Come on. I really do need, I think, another camera. I'm not spending money on another camera though. Not after just spending the amount of money that I've just spent on a Sony camera. There we go, that's just about balanced. So let's go over to number 4, over there. You can see now the multimeter. So I'm going to put one probe on ground and the other on the other ground of the battery. and we're getting 0.1, which is fine, that's what we're expecting. But on the other battery terminal, we're getting 470, 460, 50, 40. See what reading we're getting here? So that's just somebody's phone going off. So we're getting 445 on that. So that is a short. That is a short on that board. Pretty much guarantee it is, because that's the kind of reading you get. So if you were to look at another one that's ordinary, you get probably 12, 1300 ohms, and it'll go rising. It'll go rising up, and then it'd usually go to open circuit after a short while, or it'd stay around about there. It really varies, to be honest. So I'm just going to unplug and get this board out now, and then we're going to have a little look on the opposite side. I suppose I could first, before I do get the board out, could have a look under the microscope, and we can see if it's something on the top side. It's very rare to be something on the top side of the board though, to be honest, unless it's pry damage. So we'll have a little peek, we will see, and just see if there is any pry damage on this board. So let's take you onto microscope view, and then we can have a little look together and see if we can see any kind of signs of pry damage on the top of this board. So where we're looking first, let's have a little look over to microscope view. There we are. So where we're looking first, let's have a little scout around. So this is the dock connector. So I usually have a look here first. You'll notice just to the side here, this is the standoff screw next to the dock connector. So what people do is they're putting a screw in here, and they'll slip, and they'll hit one of these capacitors around here. So they'll slip, they'll hit one of these, you'll get a dead short on the board. Simple as that. That's all it comes down to. So let's have a look around here. People can have pry damage here. This is quite a common place where people slip when they're trying to pry the FPCs off. So they can slip and pull that one. I've seen people slip and pull these ones. I've seen all sorts around them, to be honest, but there's a little piece of plastic here. Looks like it's off the Wi-Fi antenna at the top, that looks like. Could be anything though. We'll put that to one side. Doesn't look like that's involved in this fault. Let's have a little look around here. I can't see any obvious pry damage on the top of the board. I can't see any long screw damage. So we're looking around for kind of common things that people do. When these phones have been out in the wild for quite some time, you'll see common things that happen. Kind of common bits where people go wrong. So let's just get this board out now then, and let's quit faffing around, and let's try and figure out what the fault is on this board, which circuit's gone short. So that is what we're going to do first. We need to figure out which one of these circuits has gone short. I reckon it's VCC main. It could be VD boost, I think it might be. I still call it VCC main. It's not. It's VDD main now. Still looks good, this. It doesn't look like anyone's had this board out yet, because all of the screws are in the right place. And you will be surprised how very rare it is to get a phone that someone's actually been into and all of the screws go back in the right place. You'd be absolutely amazed. I'd probably say 1 in 100 phones that I get, if someone's been in it, I will know straight away, because they can't get it back together right. If they couldn't fix it, they also can't get it back together right. So that's the board out. No one's been at the board. 2 shields are on there nicely, all looking good. So first place we look on the opposite side is these 4 caps at the top here. So we'll look in there just to see if they're water damaged. So they don't look water damaged to me. I'm going to have a little look for any pry damage up the top and up the bottom down here for water damage as well, before we start going underneath these shields. This is before we've even tested the board. So let's just have a little look on the microscope again. Can we see anything? Can we see anything obviously burnt out here? So not noticing anything here. Notice a little tiny bit of water damage there, but nothing to be, you know, tiny bit of moisture there by the looks of things. Nothing on these caps. Nothing to see here. Let's have a look at the bottom of the board now. Let's have a look. These are the backlight caps. So these are all looking beautiful. So let's now look and see if any of those are shorting. And then we'll have a look on the VCC or VDD main caps at the top to see if any of them are shorting. So we'll have a look at the top ones first, actually, because I'm pretty sure we'll get a good fix straight away on these. So let's have a look at one. Boom, that is a short. So you see there, we've got a 0.1 ohm dead short on VDD main. Absolutely dead short on VDD main. So if we were expecting a VDD boost short, then we'd be expecting slightly less of a short on the main. So I'm going to opt for the top shield first. Now, there's a few places where this goes wrong. We won't look at the FLIR camera just yet, and we won't even put voltage into the board. What we will do first is, sorry, I'll just show you what I'm doing here. I'm just getting the paper shield up. So we just get it under it with a scalpel, and we just peel it back. Nicely does it. Let's zoom out. There goes my fun cam. It's gone flying away. Right, let's zoom out. Let's have a look under here. And we're going to have a look, just a look, to see if we can see anything obvious here. So we're looking around. We're going to have a look around this board. Is there anything obvious? Now, you've just seen me peel this shield back for the first time, so you know I've not looked at this before. Unless I'm damn good at putting a shield back on again, this paper shield, and actually getting it so perfect that Apple couldn't even know. So we're looking around here. No shorts around here, no shorts around there. These all look nice, these caps. You notice they're all looking good. They're all looking good quality. Nothing to see here, nothing to see. All looking good, these ones. This is what we're expecting our caps to look like. So that one, yeah, it's okay. Keep looking around. This one looks a bit daft because it's got some underfill over the top of it. So they can look a little bit smouldery, even though they're perfectly good. But that's because you've got a little tiny bit of underfill over the top of it. So let's keep on looking around again. Have a look around here. I like to bend the board up as well, and we can have a little peek down the side of these. See down the side here, you can have a look at those. Then these are all looking fine. These are all looking fine. And then notice this one. That is a look of the draw. That literally is a nice, easy repair. Can you see the difference on that capacitor? Immediately, you're noticing it's completely discoloured. It's charred. It's just out of place. This is how you find nice, easy repairs. Absolutely love them like this. This cap is part of VDD main. I'm not even bothering replacing it. I'm just going to chip it off the board. Got to be careful around it because there's a lot of components around here. So I'm going to use a nice sharp scalpel. This should come off quite easy, this, because it's burnt, it's charred. So we're going to go in from the edge here, and we're going to lever against the shield like this. Going to try and get it off in one piece if I can, so I can show you it's shorted. There we are. See how nice that's come off? Okay, I just want to get my finger there so it doesn't go ping. Where's it gone? It's stuck to my finger. There we go. So now what I've done, I've just levered that off the board. But important here when you go and do this, have a look for these little bits of the part that was left behind. Make sure things like this don't go wisping away, okay, and end up touching a component next to it. So I'm going to fold that over. That one looks fine. Nothing to see there. That's okay. That's good. Right, now let's get this component. I'm going to tweezer this component up, and we are actually going to check it and see if it's shorting. So let's have a quick look. Let's see if this is actually a shorted component. So I'm going to stick this on top of this shield here, right? Just for giggles, let's have a look and see if it's shorted. I am 100% sure this is shorted. See? Yep, perfect. Now if we have a look, so I'm just going to get rid of that. That is Here, it's in my fingers, right there, and gone. Never to be seen again. It'll get hoovered up at some point. There, right, let's fold this shield back down again. Fold it down. And now let's have a look on VDD main and let's test it and see if it's worked. So, I'm going to go back to microscope view, over to there, and go, that side is a short, as we're expecting. Other side, no longer a short. We're getting 2000 ohms. No longer a short. We're now getting open circuit on VDD main. Okay, so now let's go back to our camera view. So what I'm going to do is I'm going to get some Kapton tape because these shields never stick back down again. So I always get a bit of Kapton tape. I don't like these flapping around in the breeze, these shields. Even though they're just a bit of paper, they do have metal in them. So basically they are they're shielding. They're deliberately there. They've not just put these bits here for the fun of it. If you look in these, they are actually conductive. If you peel it back, there's little tiny wires going through them. So it's for electromagnetic interference. So that's what these paper shields are on for. You really shouldn't put it back together without having these on there. It's part of the design. You're not going to get the full performance out of the phone without them being there. So it's also to stop if you push too hard on your screen and this board pushes down. If you push it down and it touches the opposite side, this chassis is metal. This chassis is conductive. So that's what you don't want to happen. So here we are. That's that. That should now be working now. I'm going to test on the VBAT again. And we're going to see a comment from there, David. Hi, David. Thanks for joining us. Not doing your repairs tonight. I don't think I've got any in from you at the moment. Yeah, I've got a nice little batch in here, and the first one's been quite a simple one. It's just been a VDD short on an iPhone 7. Love them. Absolutely love these. So I'm going to show you again what the reading is from the, let's just show you on this camera. I'll show you how the readings are. Over to camera 4, there we are. So I'm going to show you the difference now as to how it was before and how it is now, the readings on the multimeter. So before we were getting, what was it, 460 ohms on the battery. So let's have a look. Terminal 1, we've got terminal 1, which is the ground. The opposite side, look at this reading, climbing up, open. Did you see what that did then? So it climbed up, goes climbing, climbing, open. That's perfect, that's what we're expecting. That one there, can quite easily reassemble that. Let's get that back together again. Let's go back over to camera 1. Let's get this board quickly back together, and then we should be fixed on this and we'll move on to our next one. Sorry I've kind of dwelled on this a bit too long, but for people that aren't au fait with these repairs, these are the bread and butter of these are absolutely the bread and butter of repair, these are. If you're getting these in, they're great because it's the same rate, you know, it's the same rate as one that might take you half an hour to find the same fault. That didn't have to be so easy, that fault did not have to be quite so easy to find. It could have been an absolute nightmare to find. So you win some, you lose some. Some of them, you might be looking, you'll never find the fault. So that's that back on there. Let's just plug the screen in. I'm not going to turn it on and show you the screen straight away, as in kind of, you know, once it's booted, just in case there's customer data on here. I really haven't got a clue what's on this phone. Let's unplug this backlight one now. This should be charged enough. And let's look straight away. What do we have on the screen? What do we have? We've got, by the looks of things, we've got the battery logo. So you can see the battery logo coming up there straight away. Got battery logo. So the battery's dead. So, but that there is a whole load more than what we were getting before. So let's have a little look on the ammeter. How much are we drawing here on the ammeter? we should be drawing a, you know, nice amp or two. So we're drawing a full amp on that one now. 1 amp it's charging at. Brilliant. That one is fixed to me, that is. If you look at what it was drawing before, look at what it's drawing now. That is a good repair, that one. Now, you're not too worried about missing cap on VDD main. The reason being, if I look at the schematics now with you, I'll just stop reassembling this phone a sec. I'll show you. Let me just pull up. That's iPhone 6. Haven't had them schematics open since I've come in, so let me just go back, go to there, go into ZXW, and I'm just going to load up ZXW, and I'll show you in a sec what we've got. So there we go. I've just seen your comment there, Dave. Thanks very much, really appreciate that. Always appreciate all the work I get in off everybody. I just hope I can do more videos for people, really. I know people absolutely love to see the repair being done on their phone. So, you know, if I can get a phone in and I can do a repair on it, great. I'd love to do a repair on someone's phone like that. You know, it's ideal. It's great for people just being able to see. Sometimes it's easy, sometimes it's not. So let's have a little look. I'll just pull up this iPhone 7 here. So I'm going to show you. There we are. So that is that's VDD main. Let me just pull that up to here. Let's maximize it. We're going to zoom in a little bit now. So this is now camera 4. This is the schematic for the iPhone 7. Sorry, board view it is, call it. You'll notice here, so these are all the caps that are on VDD main here. So you've noticed you've got the one that we removed before. We've got a couple next to it. We've got one above it to the side. We've got a couple down here. So we've got loads all the way around here. So what these are for, these are for providing, these caps are basically for providing a little boost of current when it's necessary for a particular circuit. I believe that one there is to do with Wi-Fi, that particular part. So it makes sense because it's near the Wi-Fi chip. You know, if you look there, there's your Wi-Fi chip. There's your VDD main coming into the Wi-Fi chip. Here's some components here, and I've actually had it where this has got severed here before now along that line, and the Wi-Fi has stopped working. So I've had that before. That's how I know that that part of the board is actually related to Wi-Fi functionality. So we've had problems there. We've actually had it where that cap has burnt out so badly, it's burnt a hole halfway through the board. The phone did actually get fully operational again. The only things that didn't work on it were Wi-Fi and Bluetooth. They were the problems that we were having on that phone afterwards. Customer was happy. They mainly wanted data off the phone. So we recovered what they needed. That was it. Happy customer. So we kind of talk to people, see what they want, and you know, if they let us know what they want with the particular device, they'll either say, yeah, I need it fully functional, or there's no point fixing it. That's what we get from most repair companies. So if someone sends in a bulk order, they'll say, if you can't fix it fully, there's no point fixing it at all. So, you know, we'll look at a device, we'll go, well, let's go back to main camera so you can see what I'm doing. So they'll say to us, if you can't get it working fully, there's no point getting it working at all. Because to them, they've got to sell that phone. And if they can't sell it in as good condition, then there really is no point us doing a repair on it. Other people are just happy to have the phone up and running. They're just happy to, you know, to have functionality back again. So this one is, I think this is one for a bulk company. By the looks of things, they're selling them. So we want to make sure that everything works on this. I am pretty confident everything will work on this. However, you never know, there might be other problems. There may be other problems. We will get this booted up. We'll do a little bit of a test on it, make sure it works. But I am pretty confident that this is now a fixed phone. Sorry I'm reassembling it all, it's just that by the end of tonight, ideally, I should try and have as many phones fixed as I can, because I want to try and clear my queue down. Don't you just hate it when you're trying to put a screw in it? It just does not go the right way on your screwdriver. Has anyone got any tips and tricks on that? Because it's really, really annoying when they just don't go the correct way on your screwdriver. Sorry, little just pet hate. One of those things. I'm sure everyone has it the same, not just me. There we are, 2 more screws and then this thing can go back together. This is a bit of an arse to do as well, this one by the front camera. You wouldn't believe how many people I get where they've plugged this in the wrong way round. I get it where they've plugged the camera in upside down. So I'll have it where they've, there we go, that's in. I'll have it where this flex at the top here is actually plugged in the opposite way, so it's coming from the top. It's well awkward to get in that way. I don't even know how people attempt to get it in that way. It's an absolute nightmare reassembling it in that way. I know some people get the top shield there and turn it and flap it the other way around. I can understand that. That's quite a simple mistake to make. But really, the only person that's going to know, if I was to look inside this phone, obviously I am going to know because I've stuck some Kapton tape over that label. And then you're going to know because there's a capacitor missing from the board. But really, it's far more risk putting that capacitor on the board than it is just to leave it off. So if you've got the option, if it's just a capacitor on a really common circuit, leave it off if there's more around there. So next one, we're going to have a little look here. Which one should we look at next? I'm going to have a look at this backlight one because it's intriguing me that they've said to me that the backlight's not working. First thing we'll do is we are going to plug in a screen just to test it. So I'll get one of our screens. These are all brand new screens, so basically I'll just grab a brand new screen off the shelf and I'll use it as a test screen. The reason I don't use a single screen as a test screen I found because I was just going through screens. I was absolutely hammering it through screens because they wear out after a certain number of uses. So if I just use a screen once, use it as a test screen and then don't use it again and sell it to a customer as a new screen, it's not being used hardly at all. So it's much better way of doing it. So let's have a look at this now. Can we see, or can I see Apple logo? So yes, you won't be able to see it yourself, I don't think, on there, or can you? Yeah, you can actually see it. You can see a very faint Apple logo there. Blimey, that is a really good quality camera, that one that I've got there. So yeah, it's I've just felt it come on. It's just vibrated in my hand. So this is definitely backlight. So there's a backlight down. Let's try and diagnose what's causing it. So take that screen off. We'll put it to one side. Let's get the rest of these screws out and get this board out, shall we? So fortunately, customers sent this one in without a screen, so we got a few less screws to get out of the way. If you want me to speak less, please tell me. I'm sure I could speak less because, well, at least that way, I wouldn't have a sore throat in the end of tonight. So, let's have a look at this. Not very many people chatting. I thought we'd been a bit more chatty on here. So, not as many viewers. Please feel free, like, subscribe. Try and hit that bell icon, at least then you'll know when I'm doing videos. Don't forget with iPhone 8 you've got this screw that's underneath this little piece of foam at the top. Never forget that one because otherwise you'll end up snapping the board. There we go. So I'm just going to disconnect all of these connectors. You'll notice the way I don't use pry tools for any of these. I don't use a pry tool, I don't use tweezers. The only thing I use tweezers for here is the SIM tray. I do it from the inside. So I just get the tweezers on the inside and I push the metal of the SIM tray out. The reason why is because if you do it from the outside, you end up with the little black pin pushing in, and then you've got to push that back out again. So to me, it just seems pointless. So I just use a pair of tweezers, push the SIM tray out, I'm sure you're going to know every single phone I've done because you'll have scratch marks, I imagine, on the SIM tray. So, not much of a scratch mark. Let me have a look if I've done a little mark on there. Yeah, I can see a little tiny dimple in the middle. So, only just, but there is a little tiny dimple in the middle. So, yeah, you can tell one of the ones that I've done. So this board still feels a little bit tight there coming out. Got to be careful. Let's move everything out of the way slowly. Got to make sure everything is out of the way. I haven't disconnected that antenna at the top, so let's just click, pop that one out. Right, let's have a little peek. First thing I'm noticing, got a little bit of a mark down here, which looks like moisture. So there's a possibility this could be water damage. Do we have a bend on the board? No, no bend on the board. Now the backlight circuit on the 8 is covered up at the bottom down here. So it's not covered up on the 7, but they have covered it up on the 8. God knows why, but I think it may have had something to do with waterproofing it. Getting bloody black water seal all over the place here. So what I'm going to do now, I'm going to grab my, where on earth is my scalpel? There we are, and I'm just going to peel this back from the bottom. I prefer to do this under the microscope actually, because at least I can peel it back perfect. Let's go on the microscope, I'll just show you how it's done. I always try to peel back, there goes my Steadicam. I always peel these back under the microscope because most of the time you can get it up in one piece. Absolutely love it when I can get these up in one piece because I can get them back down again nice and tidily. So let's have a look, see if we can get this up in one piece. There we are. Torn it ever so slightly there. Doesn't matter that, you know. Doesn't matter. As long as we can try and get it back down in one piece. There we are. Oh, lovely. Beautiful. Beautiful, beautiful, beautiful. Let's pull this back a little bit now. Let's pull it all the way back. Let's see what we can see down here with this backlight. So, we're going to go zooming right down the bottom and you can see straight away, always look down here, there is our there is our filter, and you can see it's a little bit of a charred mess. So absolutely loving these tonight. Another routine repair. That there is your backlight filter, and that has blown. That just looks charred. You look at the one next to it. Look at that, looks nice. That one, all charred. Now, the way I like to do this, I'll be brutally honest with you. I'll be completely brutally honest with you here. Oh, thanks for that comment there. Yeah, so frustrating screws when they round off. Also get a lot of phones full of dirt and cement. All right, must be a lot of builders that you're getting phones from there. Yeah, I've found a lot of dirt and cement as well in stuff stuck inside devices. Most of the time it's people in the building trade. Get quite a few of them. The screws, if you do get a screw rounded off, one of the biggest tips is to solder another screw on top of the rounded screw. So basically what you're looking to do is, if I just show you here, so you get your screw like that. So this is a screw from that iPhone 8. So you get your screw, that pretend this is rounded off. So can you see it? No, you can't. So you get your screw, you get your other screw, and you basically solder the bottom of the new screw to the top of the rounded screw. Solder it on together, and then you turn the top screw. And that is how you're going to go about getting out a rounded screw from an iPhone. So handy. So yeah, it's really handy, that little tip. Another one, what's the best glue to stick iPad screens down with? So the stuff I use really commonly, this is a few nice little tricks here of the trade. First one that we use is this 3M tape. So it's 3M 9448A. So I use that stuff. There's not much left of that roll at the moment. We've got more rolls of it. And then we've also got Tessa tape, which is really common. A lot of people use Tessa tape. But this is the absolute biggest secret that we've got. I shouldn't really be telling people because it is a massive secret as to how we get our screens to stick down amazingly well and not come back up again. I'll just get her up now and I'll get it. It's on the top shelf here. It is this little beauty here. So this is Tessa Adhesion Promoter Fast Cure. So it's 60153 Adhesion Promoter Fast Cure. It's a nightmare to get hold of sometimes. Occasionally you can get hold of it dead easily. Whenever we can get hold of it, we'll always order a couple of bottles of it because it lasts a long time. So basically you're going to get the lid off it. It stinks to high heaven. So you're going to get the lid off. You're going to get a little cotton bud, dab it in, rub it around the edge of a cleaned up iPad screen, and then take the tape, take the sticky back off the tape, and then stick your screen down. Just be prepared for that screen not to come back off again, because once it's stuck down with the Tessa Adhesion Promoter and it's also stuck down with Tessa tape, it's about as good a bond as you get on the original. It is an absolute nightmare to get back off again. So please be sure that it's 100% right before you stick the screen down. Right, basically, I'm going to go back to microscope view now, and here I'm going to show you what we do when we've got this filter at the bottom down here. So what we do is, unfortunately, the easiest way of doing this, honestly, is to cut the shield. There's more, I don't know, I'm sure there's better ways of doing it, but cutting the shield is pretty much the best way of doing the job quickly. You know, you want to try and get these repairs in and out as quick as you can. I know at the moment I'm doing a video, so I could do it slower and I could show you exactly how to get down there. You could desolder this part of the shield, but I'm going to show you how I do it every time. So basically, you're going to get your scalpel, get the end of it, and we're just going to chip away there, chip away there, chip away there, chip away. You can see it quite easily. There we are. And then we're just going to cut around the edge here. So we're not cutting a massive amount of shield away. We're cutting as minimum as possible. Okay. And there we are. Try and be very careful when you're doing this, because obviously you've got so many components around here that can be damaged very easily. So, you know, you're going to be super careful around here. So that is how you just chip away a tiny bit. I don't know how much of that you're seeing on the camera. I tried to keep it in view as much as possible. But it's such a delicate thing you've got to do there to try and do that. Now, if you look at how much actual shield's being cut away there now, so you look under the normal camera, go back to camera 1. So you'll see there, you know, it's tiny. It's about probably 2 millimeters of shield I've cut away, but it's big enough to be able to get in there. It's big enough to be able to do that repair now. So I'm going to open up my, my grip now. Okay, I'm going to put the board in, get a nice grip on it. Okay, and we're going to get that component out. So let's go over to microscope again. There we are, nicely down. So we're going to see if we can get this out nicely now. So we're going to go over to camera 3. There is our component right down inside that hole where we've got to try and get to it. It isn't easy, this. I will be fair with you all. It's not actually a very easy place to get to. So I'm going to put some flux on here now, but the flux I'm going to have put on is on my tweezers because I don't really need a great deal of flux, so I might as well just use my tweezers just to get a little bit of flux down there into that hole. Okay, then what I'm going to use is my micro pencil. So this is JBC, this is the smallest tip that they do, this is. And I'm going to try and get down there, and I'm going to try and just reflow a little bit of solder onto the end of it. It might not work. I want to try and get a bit of solder on, you know, just a little bit of fresh solder on the ends. Just to try and get it on the move. Now occasionally you can get a blob on it like that, and you can actually get it to move. Sometimes you can, it's not all the time. Okay. Sometimes you can get it to move and actually lift it out with the solder. I'm going to try one more time using this method, and I'm going to use a scalpel at the same time. Not coming out there very nicely, so going to go with plan B. Not working very well. So plan B is what we have these for. These are our soldering tweezers. So I understand not everyone's got these. So we're just going to go down. We're going to go down into here with our tweezers. And, you know, I don't use these straight away because I understand not everyone's got the money to go and buy soldering tweezers. But that's how you get it out with soldering tweezers. I tried to do it the other way around. Sorry about the not being able to get it out with lower tech methods. So yeah, really, you know, it really is a good thing to have soldering tweezers for stuff like this, because it's such small work. It really is so difficult to try and do this without soldering tweezers. So I've just cleaned them two pads up there. Two nice looking pads. Alright Dave, how's it going? It's a long time no speak. Hope you're doing well as well. Just trying to do a few more streams, show people a few little tricks, how it's all done. Thanks for the last batch you sent over, really appreciated it. So we've just done that little bit now. We took that filter out. So what we're going to do now is, you got two choices. First choice is to be completely dodgy and to jumper it. Don't recommend it. But if you're really feeling, you know, proper feeling the dodge, you can do it that way. It will work. I never do it that way, because if someone was to plug a screen into this after you've done it that way, and they got the connector wrong, then they won't blow the backlight fuse, which is what's supposed to blow. This backlight fuse is here for a reason. It's what blows when things go wrong, when someone does something wrong. So the reason this filter's blown is because somebody has plugged a screen in wrong, they've had it misaligned, they've shorted out, so they've plugged it in, they've shorted out the connector by plugging the battery back in again, and boom, the filter's gone. Now if you go and jumper this in with a piece of wire, if you go and grab this wire, and you jumper that in with a bit of wire, the next thing in line is going to blow. So it's not going to be a fuse that blows. You're going to find it's the backlight IC. Now the backlight IC is going to be a much bigger job to repair. So, you know, you want to be able to choose or get the customer to have the option of replacing an inexpensive component, you know, like a backlight filter. So we're going to get a backlight filter here. I'm going to just pull one off the ribbon, put that back in my pot of backlight filters. So I'll show you what it looks like under the camera. So let's just have a little look. There we are. So I'll put that into place. There we are. So let's go over to camera 3. There we are. So notice it doesn't look exactly the same as the original backlight filter. It still does the same thing. It's exactly the same values. So sometimes you can't get hold of the exact looking components. As long as you get a component that's the same size and has the same electrical characteristics, it's possible to use that component in the circuit. So this is the same size, has the same electrical characteristics, it's fine to use in this circuit. So what I'm going to do now is I'm just going to get my tweezers, I'm going to get a bit more flux, because this chip will not go down unless we use some nice flux. So here we are, let's stick a bit of flux in the hole. Whereabouts is my scalpel? I'll use these super sharp tweezers. Loving the Hianli tweezers as well. Spend a lot of money on tools. You should always spend a lot of money on tools in this game. The reason being is it's so much easier to do a job when you've got the right tools. You know, imagine you're trying to fix your car and you've not got a socket set. You know, it just doesn't work, does it? So you go out, you buy decent kit, you buy decent tweezers, you buy decent everything really. You can do these jobs, you can do the more intricate jobs. So I'm just going to turn these on now, these tweezers, and this will just plop into position. Okay. Oh, blah. Forgot to get my tweezers. There we are. Okay. Sorry about lack of speaking. Kind of concentrating. Notice how I just nudged that component down there, just got it back into place again. You will do that every now and again. You'll find you nudge something by accident. As long as you put it back into place again, it's fine. Okay, that there. Let's just tidy that back up again because there's a load of burnt up flux. So you don't want to leave any of this flux behind. It is a terrible, nasty job that people do. I look at these boards after they've been to places. They're absolutely horrible looking. They've just left all of this flux behind. They really need to make sure that they clean the board up properly after themselves, because this, I've seen it, as soon as there's any impurities inside this flux, it will cause the actual flux to start corroding. So it'll cause the flux to all start corroding, and you'll get shorts. You'll get a short where you've just fixed the circuit. I had some bad flux once. I fixed some audios, and I had some bad flux, and the flux basically must have had a compound in it that basically rotted away, and it literally rotted away the board. So hopefully this doesn't switch on now, this compressor. Notice we're nearly clean there, nearly clean on this board. Clean it all up nice. Just have a look at this comment. Excellent. Good to see you've been all good. Thanks for always had plenty of work. Not been on the micro repairs recently, but always good to keep the knowledge up. Yeah, it is. It is so good to keep the knowledge up. You know, you really do have to keep in the game on this. Otherwise, there's a guy down the road from us. He's got a computer shop. He went on a training course, and basically he done all the training. Didn't use it for about 2 years. Decided that it wasn't for him, and basically forgot it all. He forgot all the training. He found that he was back to square one again. So it does happen. You've got to keep up to date with this stuff. So important. So what I do with this now is I get some isopropyl on my cotton bud, blow it, isopropyl, blow it, isopropyl, blow it. You're blowing it away each time. You're blowing that horrible flux away. You don't have to get rid of it all, just get rid of the majority of it. Clean that board up, make it look decent. So I'm going to go down there, get that little bit that's down in that gap. I don't really like it where there's flux touching big caps next to others. It's not good practice to get that flux there. You want to get it cleaned up as much as you can. Okay, I know I might be being a bit pedantic with this, but it's important, you know, it's important to get this stuff cleaned up. It's important to do a tidy job of it. Otherwise, you're just going to get a warranty back. So, there we are. Looks like we're all cleaned up on this. Let's look closer. Very happy with that. Very happy with that repair there. Looks good. So, now, let's stick this back in. Let's go back to camera 1. Let's stick this back in and let's see first. I'm going to stick this down. Notice there's nowhere really to put Kapton tape on this. So if it doesn't stick down of its own accord, I will get a little bit of glue and just glue the end of it. Looks like that's going to stick down of its own accord though, that one. And then once it's into the housing, then it should stick down nicely as well. So let's just pull this back. Let's stick this board in and let's see if we've got backlight again on this one. Nice, easy repair. Loving these nice, easy repairs at the moment. Sorry for everyone that's been expecting some nice complicated ones. I really don't know how these are going to pan out because literally you're seeing me opening these up live on channel. There's not really much I can do about it. If it's easy, it's easy. If it's tough, it's tough. So this one, I mean, it might not be easy. Let's face it, I could switch this on now. It might not work. So here we go. Boom, there we are. Backlight, back to life, perfect. So we'll boot it up fully. I won't let you see the screen in a minute because I don't know if there's any customer data on this. So, you know, it's very important. Let's make sure. Unable to activate Touch ID on this phone. There we go. Doesn't look like there's any data on there. Doesn't even look like it's been activated. No, it's there. It's not even been set up. So that's it. We're up and running. What we'll do now, we'll have a look in display and brightness. Let's change the brightness up and down. We like to make sure that the brightness is going full, brightness is going fully down. So fully down, fully up. Make sure of that once you've done the repair, because I've seen it where that fuse blowing, that filter blowing has caused a partial failure on the IC. So afterwards we want to make sure that the IC hasn't failed. So there we go, that's all done. Right, so that to me, another successful repair. 2 out of 2 so far on this. So there we are. That's that one done. I'll just show you that one's charged up. This was the one that we've done before, the Tristar one. So sorry, not Tristar, the board short that we've just fixed. So that's 2 out of 2 at the moment. Let's move on to the next one in a minute. Next one is going to be, what time are we on actually? We're on 9:30, so we're still all right. We're okay. Hopefully I haven't bored too many people to death. If anyone's hopefully getting to sleep, glad to supply your bedtime story. So here we are. Let's just put the rest of these screws in. There's not many to put in. Come on, go the right way. Do not make me look a fool live on air just because of a single screw. I really don't get it. When you're not on air, these things, you'll pick them up and they'll be the right way around every single time. Doing it on air, they'll go the wrong way every single time. There we go. So we're nearly there with all of these screws. I don't like to miss screws out on people's phones. If the screw was missing to begin with, it will stay missing. I'm not going to replace it for you most of the time. So if you've got screws missing on a phone, it will come back with the exact same screws missing. I am absolutely very pedantic about putting screws back where they belong. The reason being, because I've spent many years fixing long screw damage. And I know what damage a long screw in the wrong place can do to a phone. Had one today, it was iPhone 7, I think it was, either an iPhone 7 or an iPhone 8. And no fixed it. It basically, no, it was an iPhone 8. They basically, this screw hole here, They basically screwed a screw in as much as they could. They literally must have been screwing that screw into the board, went, can't get it in, can't get it in. Let me just try a bit harder. Oh, I think I might have struck gold here. They literally do. They must be screwing it in as hard as they can. I asked him about it. I said, look, you've really screwed this phone, proper screwed it. Said, did you not notice that you know, the whole thing had fallen off the board? The standoff plate had fallen off the board. He went, yeah, I did, but I super glued it back on again. I couldn't believe it, because I looked at it and I literally had the board out and I thought, that's come off the board. So I got my tweezers like I usually do, and I usually just ping it and pop it off the board to get it out of the way so I can see under it. Anyway, I tried prying it up. It wasn't going anywhere. Like, well, the fucking hell's this attached to the board? So I looked at it, heated it up with a bit of solder, and the fumes off it. You get that super gluey smell. And yeah, he'd actually super glued it back to the board. So I took it off, looked underneath it. Lo and behold, there was a 2-foot hole underneath the board coming out the other side of the chassis. No, it wasn't quite that bad. But yeah, seriously, it could have been. But yeah, absolutely so pedantic about putting screws back in the right place. I lay them out on my bench. Sorry about that, I just shook all the cameras then. I lay them out on my bench and make sure they're all in the right place and they all go back in the same place afterwards. So that's 2 for 2, that is, on that. Let's just mark that one up. That one was, so that was a BLF. So that is sorted. Put a tick on that. That is done. On this one, this was a, let's just shut this one down because it's charged up enough now. Shut this one down, slide to power off. This was a VDD main short. Tick, that one's fixed. That's backlight filter and a VDD main short fixed. You all right, Isaac? How's it going? Appreciate you joining us for a quick go on the YouTube this evening. So this one we've got here. Right, which one do you prefer to do next? Shall we do an iPhone 6, either Tristar or board short, or should we do an iPhone 7 routine audio IC? I don't know. Someone let me know. Anyone? I don't know how delayed this thing is. I really haven't got a clue. First person that types something to what I should do. Yeah, short. Okay. Let's have a little look. I don't think this is short. I don't think Isaac's seen from the start of the video that we were registering 0.006, so I believe this is an iPhone 6 for routine Tristar. I could have done a quick Tristar tester on it, but I don't really bother that much on these. So let's have a little look. Don't forget when you're doing these, when you're going back to your iPhone 6s, open them up like this, yeah? The amount of times I've done it where I've opened it up and I've flipped it like a book and I've torn the front camera flex. I don't know how many times I've done it by accident. I'll be completely honest with you, I've probably done it about a dozen times. I keep them flexes in stock because you just get into autopilot. As long as you replace it for the customer, you know, it's fine. Just be aware that you've done it, admit fault, and then change it, you know. Don't just pretend that it didn't happen. Send it back to the customer and then say the customer tells you, earpiece isn't working, front camera's not working. Oh, no, I didn't realise that. You know full well when you've made the mistake. Everyone knows full well when they've made the mistake on this. So just do it. It doesn't cost much. In the grand scheme of things, just get the part replaced. Let's just pop this up, pop these off. You'll see again, I don't use pry tools, I use my fingernails. I feel you get a far better feel for what you're doing with your fingernails. You know, you can feel where it's going right, where it's going wrong. Right, let me have a little look at this now, and I'm just going to check now on the battery. I'm going to put my black probe on the SIM tray. You can hopefully see the camera there. Black probe on the SIM tray. We should have a short on the ground side. And then on the other side, let's have a look what we're getting. So we're getting 15, 16, 1600 ohms. That there to me tells me I don't have a board short on this particular unit. This to me says it is absolutely screaming Tristar now, because if I look on the charging port, I'm getting 0.006, which shows that it is potentially Tristar. I'm getting the signs from the battery that it's likely to be Tristar because I'm not getting a board short on VCC main. So they're the two signs I'm getting. Right, let's get this board out, because you can't do a board short without getting the board out. Sorry, you can't do a Tristar without getting the board out. I'd love it if you could. If I could get a bloody board Tristar on the opposite side of the board, I would so like that. I just don't think it's ever going to happen. And I suppose the amount of heat that you have to put in it to get Tristar off, to do the repair, you know, you're still risking damaging other components, so it's still going to be safer whichever way to take the board out, even if they do decide to make Tristar. But then again, the newer phones, Tristar never fails. You know, you look at anything that's got wireless charging, any iPhone with wireless charging, I've got a stock there of around about 20 Hydra chips. I got those 20 Hydra chips when the iPhone X came out, I think, or the iPhone 8 came out, and I've not used a single one. Tristar does not fail. Hydra does not fail anymore. It just doesn't fail. Guarantee from me that I have never changed a single Hydra chip. I've changed U3300. That seems to be the next vulnerable chip in the charging circuit, but they even seem to have got a little bit around sorting that out. You know, I don't see many of them anymore. I've seen a spate of U3300s, and now I don't see many of them anymore. They've just disappeared. I'm wondering whether they've managed to fix it with software instead of, you know, maybe they've found a way of software managing power surges from the charge. So here we are. So it's our common little shield from the bottom now. Let's just take this antenna off, pop this antenna up here. So we've got the antenna just going down the side there, so that's just popped off now. We just need to get this shield off now. It's low melt solder. It should come off relatively easily. So we're just going to get it down here in the board holder. Let's just shrink it down a little bit, get it to the end. And then let's go hands-on cam, shall we? Let's just see if we can get this little hands-on cam to show you. Do it there without it falling over. Let's just pull these up a little bit. Pull these three up. Get the tripod going. Can I get this little hands-on camera so you can see what I'm about to do? Whereabouts is it? Let's just pull that down. That one. There we go. So you can see on camera 4, there's the board, right? So yeah, good idea that, Isaac. If it's not Tristar, what would it be next steps? So next steps on this, if it turns out not to be Tristar, we're going to be checking on Tigris. So if it turns out not to be Tristar, next chip is going to be Tigris. You've got your MOSFET, which could be at fault, and then you've got a small chip next to there which handles the charge controlling, which is next to the Tigris chip. I can't remember what it's called. I haven't done it for a while, but that can also go faulty as well. Generally, it's one of those. Let me just get this temperature up a little bit. So let's go on there. Right, just going to go around and around and around. Get this all melted. Sorry, you're a little bit out of so I'm going to get me tweezers just under this corner over here. I'm just going to go around and around, circles, circles, gentle pressure, trying to lift this shield up at the same time. Not loads of pressure, just gentle pressure, and you'll hear it start pinging. Go ping, 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 and that's it. Don't put it anywhere near the NAND side. You're just going to bend it up and down a little bit there now, and it should just pop off like that. Yeah? Got that off so easy. This is what happens when you've got a stupidly expensive hot air station. Things happen easily. So let's have a look under there now. Let's go onto the microscope view, and I'm going to show you the Tristar chip, which is here, over to number 3. So this is our Tristar chip. They had a wonderful time underfilling it because I think they thought it might solve some problems. Didn't solve anything. Absolutely nothing. So what we're going to do now, we're going to turn the temperature right the way down. Not enough to melt solder, but enough to make this underfill go nice and soft and gooey so that we can get it away. So what we're going to do, we're going to use our hook tool. Nice little hook tool. Absolutely love this tool for doing this. You can get it on. It doesn't risk damaging the board because the hook kind of goes under, but it works a wonder for getting away this underfill from around the chip. See, like that? Works an absolute wonder for getting all of this underfill around the chip. Okay. There we are. All we're trying to do really is just loosen it up a little bit. Loosen it up, going around the edges. So we want to make it so that this underfill isn't touching the components. Now if you do nudge your components and you move it out of place, make sure you make a note of it because you'll want to put it back again. Okay, there we are. So we're just going all the way around it. Okay. Getting the stuff off the top. Going around. It's not quite got it all from around there. Let's use this nice sharp scalpel here. Where's my super sharp scalpel? There we go. Super sharp scalpel here. I'm just going to go in. I'm going to make sure that it's all pulled away from around the chip. Because when this chip lifts up, we don't want it taking all these components with it. It turns a nice simple job into a fucking horrifically complex job if you end up doing that. So that's done. We're just going to squirt a little bit of flux on here now to assist in the movement of this chip. Going to get our tweezers now. We're going to turn the temperature up nicely. Okay, I'm going for 360 on this. Wait for it to hit temperature. 350, 360. So there we go. And I'm going to put my tweezers straight onto this chip. Okay, go. And let's move it out the way. Okay, that's how you remove the Tristar chip. Okay, so you can see there, that's come off the board. Let's zoom in a little bit. We've still got all of our pads in place. We've not disturbed any components around it. All we want to do now is just pull away some of this underfill. Okay. The reason we're pulling away this underfill is because it's going to stop our chip from going back down again. So you want to make sure it's all gone. This should be like the staple of your repairs. If there's a first repair to do, it's an iPhone 6 Tristar. Well, iPhone 6 backlight maybe first. Absolute first iPhone 6 backlight. If you can't do an iPhone 6 backlight, don't move on. Pack your tools, sell them, and don't bother. Because if you can't do an iPhone 6 backlight, you ain't gonna progress any further. Seriously, it's the simplest repair in the world. Especially if you've got micro tweezers. If you've got the micro tweezers, The iPhone 6 backlight is literally a 10-second job. You literally take the screen off, ping the backlight filter off with your tweezers, stick your new backlight filter straight back on, job done. That is it. Right, so what we're going to do now, I'm going to get a slightly bigger tip on this soldering iron, and we're going to clean off all the solder from these pads, and hopefully we're going to clean off all the other crap around at the same time. Let's just clean my tip now. Hopefully you can see what we're looking at. Right in the middle, and there we go. Just going to clean up all of these pads. There we go. Then what we're going to do, we're going to get some solder wick. Let's try and get some nice thin solder wick. That one should do. 1.5 mil. Right, snip the end off. I'm going to use our small tip again, and we're going to go around and we're going to soak up all of this solder that's on all of these pads. Okay. This is where people make mistakes now. You don't get the skill overnight to do this bit. This is just something you'll feel eventually. You know, don't pull it so hard that you're going to pull a pad off at the same time. But you're kind of following the solder wick along with the soldering iron. So you're kind of brushing the two over at the same time. If you feel resistance, don't carry on. You need to make sure you got plenty of flux down, you got plenty of nice solder down, so that you can just brush it along nicely. Let's have a look here. Let's see. It's not too bad. It's not perfectly clean. I'm not overly happy with that just yet. So what I'm going to do, I'm going to pull this bit out of the way here. Bit of underfill. Look where I've wiped across here. I just want to make sure I've not severed that, or severed that. So I've not severed any of them. So great job. You know, no problem at all. It's only exposed the copper underneath at the moment. That's absolutely fine. I'm just getting rid of the last of this. The reason you get rid of all these little bits, even though they're not in the way, is because what happens is as you're blowing the chip into place, the replacement chip, this little bit of underfill just gets dislodged, goes under your chip, ruins your day, costs you a few quid for a replacement chip, costs you a few more minutes in having to do the repair all over again. And there we are. So that's all cleaned up now. Let's stick a little bit more flux on the board. There we go. We don't need much. What we do need now is a Tristar chip to go on. So we'll go for our Tristars. Let's just grab that, throw that on top of the NAND, get our tweezers again. Okay, let's get our Tristar chip now. We'll put it into place. Look whether it's the right way. I automatically know on there that the dot goes up there because I've done a bazillion of them. You'll get to know these things eventually. Right, so that there is our Tristar chip into position, ready for us to get our hot air on the go. So let's get our hot air on the go. We want to go quite warm on there, 360 again. We want this to bed in fairly quickly. The quicker you can do this, the better. Just be careful, you're right next to the NAND here as well, so you don't want to go too hot. So we're just going to hold it in place with the tweezers. Hot air on, hold your breath. Hot air away, tweezers away. It's adhered to the board now. I've not got it on the board properly, but it's adhered. Now we're just going to heat it up and we're going to nudge it, and watch it as I nudge it. See, as I nudged that, then it went back to position. goes out, in, out, in. You know it's flowing. You know it's in a steady reflowed position there. So all the bubbles have melted. Nothing's holding it in place. There we are. That to me should be a successful Tristar transplant on this phone. So we'll clean up the flux again as usual. Clean it all up. Let's just get some flux. Let's just get some isopropyl back on again. Dab, dab, dab. Blow. Dab, dab, dab. Blow. Dab, dab, dab. Blow. Getting it all away, all out of the way. Let's look at the rest of the board. So we've blown it across the board a little bit now, so we want to make sure that it all has gone. Still got a little bit here. Happy with that now. That is quite a nice looking board. We've still got a little bit of flux residue. It's no biggie. We've cleaned up the chip. Ready now to have a little look at it. So before we put the back on, what we're going to do is we put this into here. We're going to connect up the charging port and we're just going to test it. No battery connected. All I'm going to do is check the current draw now with no battery connected. So here, I'm going to connect it, and there we're pulling 0.8, 0.9, 0.7. Perfect. That's exactly what we want. If I just show you here quickly on the Steadicam. So here's what we're expecting. So here, this is what we're getting. 0.9, 0.8. Oh, hold on. There we go. Goes up a bit. 0.7, 0.1, 0.8. That is the sign. See, now we've fixed Tristar. We're getting the correct readings again. So let's unplug the charging cable, unplug that, and let's now finish the repair. So absolute doddle of a repair this is. Absolute doddle. Lovely. Love the repair. Love how quick it is. So what we're going to do now is I'm going to show you under the camera now, the little motion camera. Sorry about that being in the way. The way I do this shield now, as I shown you last time, is I don't use hot air to reattach this shield. Some people do, some people don't. It's personal preference. It's entirely up to you how you do it. What I do, I just brush a little tiny bit of flux along the edge here. I've usually got plenty of flux on the gun without having to squirt more on. Tiny little bit of flux. You literally don't need much. You get your soldering iron, nice big chunky soldering iron this is, and I'm just going to brush it along the edge. Okay, done. Soldered on. Brush it along that edge, soldered on, brush it along there. Don't know if you can see that, but it's just soldering on nicely. Okay, just going along, we're just recreating all of those little joints. Okay, back over to camera one. Going to reconnect the antenna flex now. This little antenna here, let's just get our tweezers. Bloody hate reconnecting this little flex. A lot of people have damaged these doing that. That's back into place. Right, let's put it back in the board, like back in the chassis, shall we? So the way I do it, I hook it under those two there, stick it in there, hook it underneath there, hook it underneath that one. Okay, and we're back in again. I don't like to take too many components out. The more things that you can leave behind, the better. So let's get that. Let's get this antenna back in down here. Sorry you can't really see this. I really need some better camera angles, don't I? We will look at some better camera angles soon. So that's back into place there. Just stick the SIM tray in before we end up losing it. Let's do this. Put a couple of screws in just to hold the board in place. Okay. Gonna get this one back in here. So I put the two top ones in, and I put the one in next to the SIM tray. And I'm just going to plug the screen in now, and we're just going to see what we get. So we'll probably get battery. battery logo, because these things usually die and then people don't manage to charge them because of Tristar, obviously. Tristar being faulty generally doesn't stop the phone from switching on. So you can also test it by trying to switch the phone on. So let's just plug everything in, power it up. What are we going to get? Apple logo straight away. We're pulling 0.2, 0.1 at the moment, not massive amounts, 0.2. What are we pulling? It's usually a sign that the battery's knackered, this is. The battery's not fully charged, it's empty. We're going to get Apple logo boot loop now for a bit until it finally gets a bit of charge in the battery. Or, if it's been off for that long, the battery may be knackered. The battery may not hold any charge at all. I often find with these, after you've done this repair, you can get it doing this boot loop on the Apple logo for around about 10 minutes, 15 minutes sometimes. It's repaired. This is good. So we're getting Apple logo boot loop, but this is now the battery. This is the battery. Don't be fooled that it's something else. This is literally a faulty battery because it's probably been stuck in a cupboard until they finally found it. They've gone, oh yeah, let's get this fixed. I know someone that can fix this. Let's send it to Wayne. And that's what happens. They get stuck in a cupboard for blooming months and months on end. And you know what happens to an iPhone battery as soon as it's been stuck in a cupboard for long? It fails. So, there we go. I'm just going to do this. Put a couple more screws in. And then just to prove it in a second, I will go and get a battery and I will stick the battery in. Just to prove you that it will boot up as soon as it's got a new battery in. It'll probably come back in a minute. We're pulling 0.2 amps now. Steady 0.2. Before it was kind of fluctuating from 0.1 to nothing. What have we got? We've still got Apple logo boot loop. I often do this. I leave everything connected once I've tested it. I can put all of these screws in, no problem, while it's boot looping away or doing its own little thing. You just kind of get into a holding position with these things. You can just kind of naturally hold it in the correct position without damaging anything. So there we are. Got that one back on there. Get these two screws in and then I'll go and get a battery. I just want to test it works fully because we want to give it back to the customer fully in the knowledge that if they just go and replace the battery, this is a repair centre, so I'm happy to send this back to them with a faulty battery in. So let me just unclip my microphone and I'm just going to go and get an iPhone 6 battery. Hold on a sec. Okay. iPhone 6 battery, unplug it from there, and we'll notice straight away, I'll plug you into the Steadicam so you can see what it's doing at the moment and what it's going to do different in a minute. So there you are. Have a little look at that. Sorry, all the wires are in the way. You'll always get wires in the way. There we go. So let me switch you over to camera 4. There we go. You can see we're drawing now. So let's plug the battery in. We're drawing 0.2, 0.3 for a little blip. It might come on eventually with this battery. I doubt it though. I think the battery's too drained. So let's unplug that battery. Just clip in a charged battery. Okay, boom, 0.9. Immediately 0.9. And then this phone will now boot up. So before we were getting 0.006, I don't want to show the screen just in case it's got customer data on it. I don't think it will because I think most of these phones that have been sent in from this customer are reset. But you never know. If they've had problems where there's no power on them, they won't have had a chance to reset them. iPhone 6, I forgot how long these things take to boot up nowadays. Come on. God, they're so slow. You can see it's, you know, we've had this Apple logo for ages now. Sorry, I need to put my microphone back on again. Hopefully you can hear me better now. So we're pulling a full amp on this one now. We've got the battery plugged in. What I can do sometimes, it's a bit of a sneaky one this one is, to try and recover the battery. Let's just make sure there's nothing on the screen. No, it's a setup screen. So what you can do now, you can be very sneaky. You can unplug the battery and plug the dead battery back in. And now we're pulling 0.9, 0.7, 0.6. See, it's trying to charge this dead battery. So the phone's still switched on. It's not boot looping anymore. It's actually attempting to put some charge into this battery. This is a nice little sneaky trick that you can use to try and recover a destroyed battery. You can use one of those little battery charging things. You know, you can use the little battery charging boxes, the activator boxes, I think they're called. You can use those. You just got to be careful. I mean, this battery now, it's been discharged, I imagine, for so long that if someone tries to use it, it's going to not hold charge for very long. It's ruined. So as long as I know, I'm happy that is a fixed phone. We've got Tristar done. It's booting up. That for me is fixed for all intents and purposes of going back to a trade customer who is going to put their own battery in. They won't want me to put a battery in this phone. They can get a battery far cheaper than I can supply one to them, because obviously if I go and stick a battery in, I'm going to have to make a little bit of markup on it to cover the costs of getting these batteries in. I'm going to have to charge a little bit of time for fitting it. You know, there's little costs. So our retail price for a battery is 30 quid in the shop. Now, you know, we charge 30 quid for most batteries. So we'll charge anywhere between 30, 40 pound for a battery. That's pretty much the going rate. These batteries, they're not cheap. They're, you know, we get decent quality ones. Anyone that's getting decent quality batteries know that you can't just go and pick up a crappy cheap battery. So this now, it's gone off again. So there we go. It usually does, it detects that the battery's dead and it will just go straight back off again. So that for me is fixed. It's going to go back to the customer with a note saying battery also faulty. So let's get these screws back in again. Let's put this here, sticky label on it. So let's put, it was a Tristar, and I'll put in brackets bat also faulty. Okay, I'll put a tick on there to say that it's fixed, and there we go. 3 down, 1 more to go for this customer. So we got 100% success rate so far. I am very happy, because I don't like giving refunds, because all of these people have already paid. So thing is, you find everyone's paying now automatically because we've got the new website up and running. So people go online, they pay automatically. If it can't be fixed, we'll give a refund on the repair. You know, it's no fix, no fee. Let's have a look at this audio repair now. Let's just get my fingers down the side. Doesn't feel like it's been opened before this. This is feeling like an original seal on here. Absolutely loving this one. There we go. You can feel it. You can feel that original seal being broken. There we go. Absolutely pristine inside. Not a single screw's been touched inside this phone, and it's still got audio disease. So, you know, Apple, how can you say that this isn't a major fault with the iPhone 7s? You know, you should have extended the warranty on these things, at least to cover it. The problem is, the reason why they couldn't do it and why they couldn't cover the warranty on this thing to extend it is because every single iPhone 7 has this problem. Every single iPhone 7 and 7 Plus that's been made has got this audio problem. They can make new ones. It's still going to have the problem. They can glue it down. They've tried. I've seen ones where they've glued the chip down. They've underfilled it. It still happens. So absolutely, it still happens all the time on everything. You know, it's literally, I've fixed tens of thousands of these. This is the new method I shown last time. I'm going to do the same method again because I feel it'll work. It works pretty much every single time. If it doesn't work, you know, I'll take the phone back apart again. I'll run more jumpers. If that doesn't work, I'll do it the old-fashioned way. I'll change the chip. But let's do it the simple way first. Let's do it the routine way first. So we're just getting these screws out. Get all of these out. Get this one out. Disconnect that. I always do disconnect that one. I either do it with tweezers, or I'll do it with the screwdriver that I've just used to take the screw out next to it. So a lot of these ones I'll just use my fingers. Let's go to the standoff screwdriver. Isaac, do you find audio IC fails quicker if it's been repaired before? I find I am seeing a lot of repeat audio ICs where they've been fixed by somebody before, and because they've used low melt solder, it's cracked off the board again. They are an absolute arse to fix because the low melt solder needs to be got rid of completely before you can do the repair again. If there's been a repair on the board, another repair on the board, then it can cause the audio IC to fail. I notice a lot the audio IC fails due to screen swaps. Somebody does a screen change on a phone and it weakens because they don't put the glue, they don't put the seal back around the outside of the phone. If you don't put that water seal in, that's creating a lot more flexion in the phone. It's allowing that board to flex far easier, and you're going to get a quicker audio IC failure than you would if it was a brand new, you know, unaltered phone. But even so, you still see audio IC failing in phones that have had nothing at all done on them. They've probably just been dropped. That's all it is. They've just had a little drop, they've had a little jolt. They may have had it in the pocket, the board's just been going flexy, 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 and it's by that SIM tray. It's a weak point of the chassis by the SIM tray. Apple must know this by now. They know that it's a weak point at the SIM tray. So let's have a look for a nice scalpel to use here. Let's have a look. Go over to microscope view. We want to just cut the corner of this like we've done last time on others. I'm probably going to break the tip off this scalpel when I do it, so you know I won't have the scalpel anymore to use for other stuff. But you know, so be it. There we go. It's starting to go at the end. No, I can't use that scalpel. I was trying to use a nice sharp scalpel just to show you, but it's not going to work. Let's find the next best one. I didn't really want to use a sharp scalpel blade. Let me just grab one of these. It's falling on the floor. Ah, there we go. That's not too bad. Let's grab this one. That looks okay, that does. It's not too sharp, not too blunt, just right. So we're just going in here, straight down. We're just going to hack a little bit away, hack a little bit more away, hack a little bit more. We're all the way through. And then we just want to lift it up. Lift nicely. Okay. Lift that up nicely. Bend it over, bend it back, bend it back, bend it back, bend it back. Snaps it off. Sticks it in the pile where we have all the rest of them, where we have a nice little bazillion of them stacked up. Okay, we push this little bit down here. Push that little bit down there. Right, take that out. Get our wedge. Wedge, wedge, wedge. There we are. Right, sorry for showing you my horrible nails. Get our wedge. Let's have a little look down here. We can see. Right, now we need a super sharp. We need a super sharp scalpel. So let's go in and we're just going to chip away here. Expose the solder underneath. That's it. Exposing that bit of solder. Now we just need a little tiny bit of flux. Careful not to break that chip. You know, they are made of glass. Horrifically fragile glass is what the disclaimer should be. So, now let's get our little piece of jumper wire. Get our solder tip. We're going to change it for the, we're going to change it over now for the super sharp solder tip. Going to stick our jumper in down here. Push it down, hold your breath. Okay, that's stuck on. Okay, let's get our scalpel. There we are. Snip it off. That's it. That's that bit done. Right, let's get our hot air. Make sure we're not too hot. We don't want to be scalding things and reflowing this chip anywhere. We don't want to be damaging baseband. There we are. It's all we need, a little tiny bit of heat just to move that flux out of the way, get it on the move. Push it over. Push it into position. Smush it under. Get our soldering tip. Our other tip. Get some, get a nice big blob of solder on it. So we want a huge, nice big blob of solder. I'll show you on the mobile cam. There you are. You're going to get a tip and you're going to get a blob of solder on the end of it like that. Okay, going to go back to Microscope. And here, we're going to go with our hot air, with our soldering iron at the same time. On 3, 2, 1, touch. Just reflowed. Off. 2 or 3 seconds of heat. You'll notice we've got a little blob of solder left behind on top of the chip. Okay? Just get a fresh bud and we're just going to blob it on top, wipe it sideways, and we're going to turn it round. Do not use that tip again of your cotton bud. That's it. You have to bin this cotton bud now because you've got a little tiny piece of solder buried somewhere in it that you could end up dropping back on the board again. Okay? Tidy it up. Throw that cotton bud away. Let's get a little bit of compressed air. Okay. Get all that flux out of the way. There we go. Nicely done. Check that out. We've now got a jumper running from one to the other. That's how we want it. It's exactly how we want it. So how quick is that, right? Then I'm going to go back over to here. Going to cut our pieces of Kapton tape. Okay, going to do that. One piece on. Cut our Kapton tape again. 2 pieces on. Now there is something I have done on this and I didn't show you. It doesn't matter, it's not part of the repair, it's part of my warranty process. So as I done that then, I just marked this board. I didn't show you on the microscope, I did it deliberately so nobody knows where it is. But I do this for warranty purposes. I just put something on the board that I know is there that's for warranty purposes. So now what I'll do here, I'm going to get a pen, I'm going to do the visible warranty now. So I'm just going to write on today's date, 1705-170-521-BR for bit repairs. And I'm going to write that on the back. There we go, nice and clear. Nobody really knows what it is. They just know the date that this repair's been done, and I know it's been done by me. I also know it's been done by me because A, the method that's being used, I don't think I've ever seen it being done like this elsewhere. It won't come back to me, this. This will not come back to me, this phone, for a fault. So, occasionally if more of the pads go, but that one won't break again. You know, some of the additional pads can sometimes break if it's subjected to another trauma, the phone. But, you know, we fixed the problem at hand. We've not took the chip off. We've not played around with all of the delicates inside, heating it up loads, risking baseband. That's the biggest thing that you're risking, is baseband when you're doing this repair. You know, if you can do it without risking baseband, brilliant. Let's do it. Let's do it in the way that least risks baseband. What time are we on now? So we're on 20 past 10. I'm going to go home in a minute. I've done 4 repairs. It's been a long night. Not done as much as I wanted to, but still I've done 4 successful repairs. I've shown you all how it's done. Let's just click the home button here, tap there, voice memos, and there we go. Play. And there we go. Fixed. Done. That's it. It will work in a call as well. I will test it in a call, but that's it. That's the repair process. So that is all we do with these. Switch it off for the time being. It'll have another stage of testing later. We've started testing things a little bit more now on these phones. We've got somebody else that'll come in, come over and just do tests on things before they go out. We found that some were going out and, you know, there was just little niggling things. You know, we might get the odd one that goes out and there's just something's been forgotten on it. Something minor has been forgotten. So we like to now catch them before they go out. So let's get this back together again. I'm not entirely sure how long that just took as a repair. Has anyone got a timer going? Really appreciate it if you could share this channel in places. I do really want a load more viewers. You know, I'm not trying to make money out of this. I'm trying to help people. If I can help people, great. You know, really appreciate it. I don't mind you sharing the links on Facebook. I know I'm not on Facebook myself very much. I just don't really bother with it. I can't be doing with it. It's just one of those things that I've never really bothered with. I know some people love it. They love the assistance that you can get, the sense of community. I don't know. I've never really got that kind of sense of community thing until I can do like a YouTube video. YouTube video, it's very direct. You know, you're straight in. You're throwing yourself into the sharks. Because I could do a repair now. I could slip. I could screw something up and it could take me 2 hours to fix it. You know, that's just the way it goes with these repairs. You've got to take the rough with the smooth. You've got to try and be as good, as steady as you can. And just try and get through your repairs. But if something does go wrong, admit it, stop, spend the time correcting it again. There's sometimes where the customer will say, you know, I just don't bother, just move on to the next one. If you've got a large batch for them, and they just want you to get through that batch. Like sometimes if the audio IC is filled and I've got a big audio IC batch, I'll leave the underfilled one and I'll send it back at a later date when I've got past the majority of my queue. So I think that's happened recently as well. You know, I just stop. Don't bother spending tons of time on it when you've got a huge big queue. Don't go and let loads of people down because you're stuck on one device. I did it a little bit myself today. I had an iPhone X for Face ID, higher lower repair. I couldn't get it working. I had to refund the customer, but I just couldn't do it. It just would not work. To the best of my ability, I could not get it going. I probably spent about 3 hours on that phone, wasted 3 hours on there when I should have just quit while I was behind. You know, so I don't know. Sometimes you got to think, audio IC, tick, there we go. That's done. They'll all go for further testing. That's 4 units for that one customer, all done nice and successfully. That's it for now. Really appreciate you all joining me. Thanks very much. I'm going to try and do this more regularly. If you've got any suggestions, please put them in the comments. It really helps promote the videos as well if you do some comments for us. Yeah, thanks for joining me. If you need to order any of these services, www.bitrepairs.com. Please like, subscribe, hit that thumbs up if you've enjoyed the video. That really helps. Everything goes towards the YouTube algorithms these days. So yeah, thanks very much for joining me. Good night to everybody, and yeah, great. Thanks very much.